Hi everyone. Today we'll see the introduction to electric drives. So what are the applications of electric drives? So wherever the motion control is required in a large number of industrial and domestic applications. So like transportation systems, in electric vehicles, electric cars, machine tools, fans, pumps, robots, air conditioners, washing machines, rolling mills, paper machines, textile mills, etc. are the applications of electric drives. So here if you see from the low power application to high power application, we can find almost in all the electric devices or in domestic as well as the industrial applications we can find. So here in CPU you can find the fan. In that fan that may be a few watts power electric drive. If you go for air conditioner, washing machines, that may be tens of watts. If you go to the textile mills or paper machines, there it may be in kilowatts. If you go to the traction applications, that is in megawatts. So like this, and in all levels you can find the electric drive applications. Wherever some motion control is required, there the electric drive application is there. So what is mean by drive? The systems which are employed for motion control are called the drives. So the systems or the mechanism which is employed for the motion control is called the drive. So these may employ any of the prime movers. The driving force may be our prime movers such as diesel or petrol engines, gas or steam turbines or steam engines, hydraulic motors and electric motors for supplying this mechanical energy for the motion control. So among all these prime movers, if the drives are employing the electric motors, then that type of drives are called the electric drives. So the drives employing the electric motors are called the electric drives. So you may have other prime movers also, but mainly we are focusing and discussing here on the electric drives. So what are the advantages of electric drives? Because if you compare with the other type of prime movers or other type of drives, the electric drives have over advantages. So one is absence of mechanical gears. By using these electric drives, we are not experiencing that mechanical gears, that is speed is changed electrically. Your drive speed is changing electrically means no need of mechanical gears. You can control the speed instead of using that gear ratio. Directly you can control the speed from in certain ranges you can control. But if it is mechanical drives means you have to go for the gear ratios to get the different speeds. So second one is electric braking can be employed. Even by using the electric braking also we can employ electric. And they have flexible control characteristics. So control characteristics means it may be speed, it may be power, it may be speed torque characteristics. So these electric drives have flexible control characteristics. And the next one is the steady state and dynamic characteristics of electric drives can be shaped to satisfy load requirements based on your loads. Loads here, it may be fans, it may be pumps, it may be washing machine or air conditioners. So to satisfy that load, what is the requirement? Speed torque characteristics. So we can shape that speed torque characteristics are in both in steady state as well as dynamic characteristics can be shaped as per the requirement of the load. So fan requires certain 5 speed levels. So that is possible with these electric drives. Just by adjusting the knob, we are getting the load requirement. The load is nothing but fan requirement. So that's what it means. And the starting braking is usually simple and easy to operate. So few starting methods are there in electric drives. For braking, few braking methods are there. So generally the starting braking, these are called the transient operations. So these transient operations also, it is usually simple and easy to operate. So next one is availability of power semiconductor devices like digital ICs and microcomputers have made the control characteristics even more flexible. Nowadays we have more and a wide variety of power semiconductor devices and digital ICs. So by using this uh, power semiconductor devices, we can control more smoother the speed control, or to meet the load requirements, we can use a number of wide variety of switches which suits for that particular applications. And next one is they are available in wide range of torque, speed and power. That's what I have told. So if you can find the fan in CPU, it is in watts range. If you go for air conditioners, it may be in tens of watts. If you go for textile, means it is in kilowatts. If you go for traction applications, it is in megawatt range. So electric drives you can find in almost all the range of applications. It may be torque, speed and power. By using these electric drives, you can control the speed from wide range of speed control is also possible by using this electric drives in a smoother way without using that gearbox. So by avoiding that mechanical components like gearbox, here you are getting the more efficiency. Your power losses will be less. Your energy losses from the end to end, it will be less. That's why your electric motors have high efficiency. Electric motors are having a high efficiency means electric drives are having high efficiency. So they are adaptable to almost any operating conditions such as explosive, radioactive environment, submerged in liquids, vertical mountings and so on. That means as these are electric drives, this doesn't contain any liquid or any harmful gases. We can place these electric drives in almost all environmental conditions. That's what it means. Even we can keep it vertical mountings like wind turbines. Even submerged motors also you can find, right? That's why submerged in liquids, explosive or radioactive environment, wherever it is required, because with that such environmental condition this is not gonna damage. That's why it is adaptable to almost any operating conditions and do not pollute the environment. At least by using these electric drives, that place do not pollute the environment. To generate the power, the pollution, little pollution is there, but by using that electric drives in that place, in that application area, it do not pollute like diesel or some other drives. It do not pollute the environment. And it can operate in all four quadrant speed torque plane. So this four quadrant speed torque plane is required in almost all the applications. So by using this electric drive, we are getting that four quadrant speed torque characteristics. Four quadrants means in forward motoring, forward braking, reverse motoring and reverse braking. These operations we are getting by using these electric drives. Unlike the other prime movers, there is no need to refuel or warm up the motor. They can be started instantly and can be immediately fully loaded like diesel drive is there. So to start the diesel drive, it requires some minutes of time. So but electric drives does not require that starting time. It can be immediately go to the fully loaded compared to that diesel drives. That's why that advantages are there, and they are powered by the electrical energy, which has a number of advantages over the other forms of energy. Obviously, whatever the advantages of electrical power, those advantages will be adopted to these electrical drives, because we are using the electric power only as a energy source to these electric drives. So coming to the block diagram of an electric drive, so these are different blocks of the electric drive. So one is source. Source is given to the power modulator. Here sources may be, we'll discuss one by one module separately. As of now, this is block diagram. In this block diagram, we have source, power modulator, motor, load. So from source to load, in between you have power modulator and motor. Power modulator, it is power electronic controller, or you can use the power electronic devices to design this power modulator. Just if you are using AC and your motor and load require the DC, means you have to go for the rectifier. If your source itself it is DC means, and but you however you require the you have to operate the AC load means, then you have to use the inverter, and corresponding motor is induction motor or synchronous motor. So likewise, power modulator will give the proper power, required power to the load and motor. The motor and load are connected with a shaft, and from the motor a sensing unit will sense the speed, and that speed will be sent to the control unit. So the control unit need to adjust the firing angle of the or modulation index or firing angle of the power modulator, so that again it need to control the voltage to the motor. Indirectly it needs to control the speed of the motor as per the input command. Here input command we are giving it to the control unit. Input command is nothing but, let us take that input command as reference speed. If your load required some 1000 rpm speed, you need to give the input command as 1000 rpm. Like your home application like fan, it requires some, it needs to run with 3 speed means on that regulator, fan regulator. By keeping that, you are getting certain speed. That input command is here knob, fan regulator knob, likewise. So by providing that input command to the control unit, it will compare that input command with the actual speed which we are getting from the sensing unit, and both will be compared, and that error need to be processed through the controller, and it need to generate the required firing pulses to the modulator, which will change the output voltage of the power modulator. That power modulator output voltage will be applied again to the motor, and that motor will run with the, it will try to run close to the input command speed. Again it will be given to the load, right? So this is continuous process. This is in a closed loop and it is continuous process. For example, if after applying the 1000 rpm, but initially if load is running with, or if shaft is running with the 1200 rpm, the 1200 rpm is sensed by using the sensing unit. However, we have given the input command as a 1000. That difference will be processed through the controller, and it will adjust the firing angles of the power modulator, and that will again increase or reduce the voltage at the motor. Now the motor will try to run near to the 1000 rpm, that may be 1050. Again 1050 will be sensed, again firing angle will be adjusted. Next time it may be 1030, next time it may be 1020. Likewise, it will try to reach that 1000 rpm, and it will oscillate around that 1000 rpm, because this is closed loop. So you will not get the exact 1000 rpm, but maybe 1001, 1002, likewise. So depends on your controller, you will get that oscillations. So this individual block diagrams we'll see one by one. However, we'll see in the next session. Coming to the description of the block diagram. So here load is usually a machinery which is designed to accomplish a given task. So the task may be, for example, if you take fans, pumps, robots, washing machines, machine tools, trains, drills, etc. So all these are the loads. To meet or to complete the to complete the task, load is designed, and usually load requirements can be specified in terms of the speed torque demands, and the motor is chosen accordingly. Your series motor or shunt motor or induction motor or synchronous motor is chosen based on the load requirement. At starting, do you require high torque or low torque? Whether your torque need to be proportionally with the speed or inversely proportional to the speed or other requirement. So that thing, generally load requirement, based on this load requirement we need to design or we need to go for the selection of the motor. Next one is power modulator. This power modulator performs one or more of the following four functions. One is it modulates the flow of power from the source to load or motor in such a manner that the motor is imparted speed torque characteristics required by the load. So power modulator function is it needs to modulate the power from the source to load or source to motor. If it is AC, load requires DC means AC to DC. If it is source is DC, load is required AC means DC to AC. Such a converter we need to use, either rectifier or inverter or DC to DC converter. If input is DC but controlled DC required, then DC to DC converter, AC to AC, voltage controller and frequency controller. So the power modulator function is, one of the function is that. And next one is during the transient operations such as starting, braking and speed reversal. The starting of the motor, braking of the motor and the speed reversal of the motor are called the transient operations of the electric drive. During these operations, it restricts the source and motor currents within the permissible values. The excessive currents drawn from the source may overload it, or it may causes a voltage dip. To avoid this problem, voltage dip or damage to the loads, to avoid these problems, this power modulator will control or it will try to keep that levels within the limits. Next one is it converts the electrical energy of the source in the form of suitable to the motor. That's what I have told. If the source is DC and an induction motor needs to be employed, then the power modulator is required to convert DC into a variable frequency AC. And last one is it selects the mode of operation of the motor, that is motoring or braking. So by using this power modulator, we can select the operation, required operation, that may be motoring mode, braking mode, both in forward direction as well as the reverse direction. Just by adjusting the firing angle, we can get the required operation in any quadrant among all the four quadrants. So that it selects the mode of operation. That mode of operation, it may be first quadrant, second quadrant, third quadrant and fourth quadrant. It may be forward motoring mode, forward braking mode. You need to adjust the firing angle to get that forward braking mode. Reverse motoring mode, how to get that reverse motoring mode? Both we need to reverse, both voltage and current we need to get in a negative or reverse. For that, how your firing angle need to be adjusted, which type of converter or power modulator you need to use. So that we will see. So next one is